Is it
It's up? Oh, that's good. Hello, everyone. Thank you for attending this truly lightning talk. Count on floating point, I'm going to give you a good feel for how to use a type exported from the package DoubleFloats, Double64 to your own benefit. All right. A double float is literally two Float64s side by side. One holds the high part, the other holds the low part. The right way to think about it is stretching the significand, kind of leaving the rest the way it is. Double64s are good because they're performant relative to other ways of getting extended precision. The Float 128 type comes from the quad math package. It's essentially a wrapper around an assembler library. And big floats, you know, this is just a 128-bit precision version of that. So you can expect to get your somewhat more precise results a little more quickly using Double64s. And again, as they teach you in CS1, this isn't a panacea. You can certainly have problems that are so ill-conditioned and poorly specified that no matter what you do, you're going to get nonsense at the end. But for most of the work that we do, that isn't the case, and having a little more precision will get you additional accuracy at the end of the day. For anybody who wasn't sure, Julia does just work well. All right, what we do, we write really good code, and we use data that we have taken care to make sure is reliable. Our routine, we provide context, and the context that we provide is usually well received. We're an august group of engineers and designers. With double floats, the Double64 type, this is what we can do with so little effort by taking the data and remapping it to the higher resolution type, the Double64s, then doing exactly the same thing, the provide function, taking the results and mapping them back to Float64s. What you have almost always is results that are somewhat more reliable. If you actually go in and check how many bits are accurate, you will see, I've seen, that the least significant bits become a whole lot more reliable. And while Double64s give you more than just the Float64 bits, it's all designed to be used just as if it were Float64s, and it presents the results the way Float64s look, so that the extra precision is sort of behind the curtain, and if you leave it there, it will inure to your benefit. And you can do this even more simply, right? You can have your own process and just check it. Run it with a few examples of test data. You expect your more resolute data, your more reliable results to match up with the way that it's run as Float64s. And if it doesn't, something somewhere is awry and needs to be addressed. That's a really good use of the package. And that's all I have to say on the matter. Thank you very much for your attention.
Any questions for Jeffrey?
Yes.
Please.
Can you explain why you get faster performance than Float 128?
Faster than, because Because 2.5 years and 5 versions of effort. That's really it. There are 2 underlying technologies, and I will try to write about them to make them available in the proceedings. It's more involved than a lightning talk. There's something called error-free transformations and another way in which I treat successive levels of function calls that combine to give you that advantage. Yes?
What's the computational overhead of like the double 64 versus the regular 64? Is it just like twice?
Oh, it varies quite a bit. It can be close to comparable to maybe 10x overhead and for trig. And if you do some things with matrices are really quite fast, and other things with matrices are really quite slow. So it varies a lot.
Do you have any like commentary on what's fast and what's slow, like documented anywhere, or?
Well, yeah. There are benchmarks, and to be responsive to your question, I will add specifics about that to the documentation. Yes?
Does this work well with GPUs? So can I just create a Q array of double 64s? Will it work?
I don't know.
Okay, I think we can do another very big thanks to Jeff. Now I'd like to request our next speaker, Shamek.